In this lesson, I want to introduce something we've not really had in Azure before. That's the ability for VMs to actually share a disk. So in this video, I want to talk about shared disks in Azure. And I want to take a quick step back. When we think about having highly available services, we use some kind of clustering technology commonly. So in Windows, this could be Windows Server failover clustering. In Linux, this could be Pacemaker. And the idea is essentially I have multiple nodes. And those nodes operate as a collective unit to run compute workloads. Now this could be active-passive. So in active-passive, I have some service that only ever runs on one node. The others are kind of sitting there waiting, or they're running other services. And the idea is this workload could actually run on any of them. So if this node needs maintenance, well then, hey, I'm going to take that and I'll move it to another node. If a node fails, another node can kind of quickly take over from it. So we have this ability to provide resiliency of our services, but also it could be scale. It might be, hey, I can actually run the service on multiple nodes, providing that same overall service, and I'm just distributing the workload. Then when we think about clusters, there are some models where there is no shared storage required. Maybe each node just has, hey, it has its own sets of storage, and it replicates the data between them. Great. There's other workloads that need shared storage. And we've not been able to do that in Azure. We don't have the ability to share a disk. Now, some of the things we could do with Storage Spaces Direct. With Storage Spaces Direct, hey, I can have local storage on each cluster node, and then essentially what happens is that storage is kind of virtualized away into what looks like a shared disk. So the nodes see it as shared storage. In reality, it's storage on each node that's replicating and making the data resilient. It replicates, it mirrors, it does parity, whatever I configure. So this is the model we could use. I'd have multiple disks on each node, and I'd kind of use that Storage Spaces Direct to create a virtual shared disk for all of the nodes. Or I could use other services. Maybe I'm using Azure Files. I could use Azure NetApp Files. Maybe I could use Blob. Again, it's some shared area all of the nodes could access. But there was no ability to just, hey, have a disk and connect it to multiple virtual machines. I can dynamically remove disks around. I could remove it and then add it to a different one. They can't all be connected at the same time. Well, now we do. So the idea of shared disk is I can take a premium managed disk or an ultra managed disk, and I can think about, well, now I can have a certain number of VMs. Now, based on the size of, for example, the premium, the ultra disk, it has a max shares attribute. And that tells me, well, how many VMs can connect to that disk at the same time. So what I think about doing is, okay, well, I have, let's just say 2. And in the demo I'm going to show I have 2 nodes. Now each of them has their own OS disk. I can't share an OS disk. But now what I'm actually going to do as well is I'm going to create, in my case, a data disk. Now I'm using a P15. That's the smallest disk that supports max shares. So this is going to have a max shares value of 2, meaning I can connect 2 VMs to it. So I'm going to attach this disk to 2 VMs at the same time. Now these virtual machines today, this is in preview, so this could change. They must be in the same proximity placement group. So remember, proximity placement group is all about proximity. It's going to put them as close together as possible, try and reduce that latency between them. So the virtual machines that I'm going to connect to a disk need to be in the same proximity placement group. But now I can use this for things like SQL clusters, scale out file servers, regular file servers, any kind of workload that wants a shared disk. And this supports things like SCSI2 persistent reservations. That's what I need for a lot of things to make it a shared disk. I can make this a cluster shared volume in my cluster and then run workloads against it, which is exactly what I'm going to show you. So in the demonstration, and again, I've got a max shares of 2. If you look at the bigger size premium SSDs, I can have larger values. I could connect 5 nodes to it. So it just depends on how big that premium, that ultra SSD is going to be. But essentially that's all there is to it. I have a managed disk, it's a data disk, I'm connecting it to multiple VMs in the same proximity placement group, and they see it as shared storage. I can use it as a cluster shared volume. I could have it connected to all of them and move it for a regular file server. Now normally in Azure, if I create a cluster, we have a slight problem. Each node has its own IP address. And historically, the cluster requires an IP address as well. So what we historically did was we would create kind of a load balancer. The load balancer would kind of have an IP address, and that would become the cluster's IP address. If I had other workloads in the cluster that required an IP address, I would have to use load balancer. Windows Server 2019, which is what I'm going to use, introduced the ability to use a distributed network name for the cluster. What that means is I don't need the load balancer. Rather than it having a separate IP address for the cluster, each of the cluster nodes will register their IP for the cluster IP address. So there'll be multiple entries in the DNS. So I don't have to have a separate IP for the cluster anymore. And then my workload is going to be a scale-out file server. Well, the great thing about a scale-out file server is that already uses a distributed network name. So my cluster is going to use a distributed network name. My scale-out file server uses a distributed network name. So I don't need an internal load balancer. And what's going to happen is I'll then create a share on the data drive that will be served up by the scale-out file server service. So it will be accessible from either of my 2 nodes. But the data, that shared disk, is that managed disk. And so for the first time, we're going to have multiple virtual machines connecting to the same managed disk. So SQL FCI could use this. Again, my scale-out file server could use this. Anything that needs a shared disk, I'm going to be able to use this capability. So let's go and see this in action. So I want to just walk through my demo environment. The demo itself is very unexciting. Essentially, I'm using West Central US. That's where the preview is currently active. So I created a resource group, and then I created a shared disk. Now I used an ARM template to create the disk. This is on the Microsoft documentation. Really the key point you want to focus on here is the size of the disk. So this was a 256 gigabyte. That made this a P15, and the P15 allows up to 2 shares. So I've set the max shares value to 2. If we look at the documentation, we can see, yep, the P15 and the P20, they support up to 2 shares, the P30, 40, 50 up to 5, and then the P60, 70, 80 up to 10. And that's all this does. It creates me a premium managed disk of that empty 256 gigs with that 2 max shares. Then I create a proximity placement group, again in the West Central US. I create an availability set. Now right now, the documentation stipulates you have to have update and fault domain counts of 1. I don't know if that will change when it actually comes out of preview. And then I just create 2 VMs in the same virtual network. I install the anti-malware extension and make them join the domain. I create a local credential, create a diagnostic storage account. It is an S variant, so I can use the premium SSD. And then all that's actually done here is I connect the shared disk. So I run through this twice to create VM O1 and O2, and I attach the same disk to both of them. There's no special flags. I'm just connecting the same disk to two different virtual machines. And that's all this does. If I look at the end result, my resource group, you can see I've got my availability set. I've got my proximity placement group. I've got my, if we scroll down, I've got my diagnostic storage account. I've got my two virtual machines, each of them with their own OS disk. I have my one shared disk and the network interfaces. If I was to look at one of the virtual machines, we would see, yep, it's connected to that single shared disk. If I was to look at the other virtual machine, so I've got the same disk connected to two different virtual machines. Now, all I did then was essentially I installed the failover clustering feature in both of the operating systems. I bounced them. I ran the test cluster and I saved away the test results because it's actually pretty interesting. Here I'm connected to the FC01 node. And if we look on its file system, where I saved away the cluster validation report and we open that up, it will show us all the tests that it did. And there's really one I care about in particular. So notice I've got some warnings. The network's going to complain because I only have one network. We don't care about that in Azure. Normally in a physical environment, we care about having multiple networks for resiliency. We don't trust one network. In Azure, this is all software-defined networking. The underlying physical fabric is highly resilient, so I don't care that there's only one physical network. But the tests I care about are the storage. These were all successful. Now look at these. Things like, hey, SCSI device, SCSI 2 persistent reservations, SCSI 3 persistent reservations. Test disk 0 supports persistent reservations. So it found, hey look, there's a shared disk we can use. Fantastic. So then I actually went through and created the cluster and I specified the management point network type to be distributed. That is that distributed network name. So it doesn't have to have a separate cluster IP that I'd have to host through a load balancer. And I changed it to use a cloud witness. I set up a file server role on both the nodes, and I just created a scale out file server. So here I'm actually looking at the cluster. You can see I've got two nodes in the cluster. If I go to my nodes, two nodes both up. We can see I'm using Cloud Witness. So Cloud Witness is just a blob in a storage account. I don't have to host another VM. It's very small. It's basically a 0 bytes. It doesn't really cost me anything. I have one network. That's fine. It's Azure. And then if I actually look at my roles, well, I deployed the scale out file server that also uses a distributed network name. For my storage, you can see I have a cluster disk and it is a cluster shared volume. So it's accessible by both the nodes at the same time. If I look at my file system on node 1, I will see cluster storage, volume 1. I can see my shares, and there's some data in it. If I was to connect to my second node, this is the other node in the cluster, I'll have exactly the same view. So from here, we'll go and have a look at its file system. And once again, we're going to see cluster storage, volume 1, shares, data. They're both accessing it at the same time. So that's showing that shared disk in action. Both nodes are accessing it. I've then created, from that role, I created a share. So I've got my scale out file server, and then I created a share just called data to just kind of show this in action. Now, if I jump out for a second to my sort of main
machine that's on the same, it's actually not the same virtual network, it's on a peered virtual network. I want to show kind of this in action. So that distributed network name, if I look up the name of my cluster object, it resolves to both the IP addresses of the two nodes. It doesn't have a separate cluster IP, it's a distributed network name. The same way, if I look up the scale out file server, it also resolves to both of the nodes' IP addresses. So that's that distributed network name in action. I don't need a separate load balancer hosting an IP address that it's going to use for those things. Now, I have, if I do let's have a look, net use, I've mapped a drive to that share. Now this could be connected to either node. They're both active. I can look around there. I can see the files. I can open it up. There's my dog. And just to kind of show, if I do a get SMB connection and format this as a list, you can see it's continuously available. So that's the attribute of that scale out file server. It will actually have like a witness going on. It will tell me in advance if the node goes down, so I can go and connect to another node. But it's given me this resilient capability. So that's it. It is a very simple demonstration. But the big deal, I have a physical shared disk. And I say physical, I just mean it's not virtualized by storage spaces direct. It's actually a single managed disk that's connected to multiple virtual machines at the same time. This does open up a huge number of new scenarios.
So I hope that was useful. I hope that made sense. If it did, please give me a like and subscribe and share the video. And I'll see you again soon on the next video. Take care.